Our last operation with decimals is division. And when we divide, we're going to start with dividing a decimal by a whole number. We're simply just going to place that decimal directly above the quotient, or sorry, above the dividend, which means I'm putting the 304 and 500ths inside and the 5 on the outside. This decimal will go straight up to just above the dividend. And then we'll just divide like normal, and really we can just sort of ignore the decimal. So 5 does not go into 3, but it goes into 36 times. 6 times 5 is 30, and that gives me 0. I bring down the 4, and 5 doesn't go into 4, so I have to put a 0 as a placeholder, but I can bring down that next value. 5 does go into 40 8 times. 5 times 8 is 40. And then I would bring down the 5. So 5 goes into 5 one time, and I don't have anything left over. So notice in this case, it ended quite nicely, and that decimal in the dividend went directly above it to be in the quotient. Now, if the divisor does not go in the dividend evenly, we're going to not use a remainder. So we kind of used a remainder for a little while before, just till we got to this point. So now we're not going to use a remainder. We're going to keep adding zeros to the right of the dividend until the decimal either terminates, which means it stops, like our last example did when we got a final answer with nothing left over, or if we notice that there's a pattern where it's going to keep repeating. So for my first example, I have 58 and 37 hundredths that will go inside and a 2 on the outside. Again, I'm going to bring the decimal straight up. So 2 goes into 5 2 times. That means I'm subtracting 4. 5 minus 4 is 1, and I bring the 8 down. 2 goes into 18 9 times, and I get 0. So I bring down the 3. 2 goes into 3 one time, and I bring down the 7. 2 goes into 17 8 times, but notice I'm at the end of my question and I'm not done because I still have a remainder. So this is where I would add a 0 to the dividend that I could then bring down, and now 2 into 10 5 times, so we can see that this one will stop, and I get a final answer that was a terminating or stopping decimal, one that stopped. Sometimes it's not going to stop, it's just going to keep going, but we'll see a pattern. So let's try our next example. I have 8.5 and I have 3. Again, leave the decimal right where it is. 3 goes into 8 2 times, so I subtract 6. 8 minus 6 is 2, bring down the 5. 3 goes into 25 8 times. 8 times 3 is 24, and then I get a 1. I'm going to add a 0 so that I can bring it down. 3 goes into 10 3 times. 3 times 3 is 9. When I subtract, I get 1, and again I can add a 0. Bring down the 0. 3 still goes into 10 3 times, and now I can see that if I kept doing this, I would keep getting 3s, 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 3s. So this is one that's going to repeat because we have a pattern of 3s that will go on forever and ever and ever. The way that we would write that as a solution is 2.83, and since the 3 is repeating, we put that repeating bar above the top of that one. So 2.83, and that 3 is repeating. If the 8 and the 3 were repeating, the bar would go over both the 8 and the 3. So be very careful where you put that. If the divisor isn't a whole number, then we're going to have to move that decimal place because we need to divide by a whole number. So I wanted to give you an example using fractions so you could see what was going on. If I'm dividing, this is the divisor on the bottom. Notice this was not a whole number, but I moved it 2 places, or took it times 100 essentially to make it a whole number. But if I did it there, I have to do it to the top so it's the same answer. So moving this 2 places gives me negative 576.3. Now, typically I don't write it as a fraction. I would go ahead and write the original question on the inside and the divisor on the outside. And from here, I would not put that decimal straight up. I would go ahead and move this 1, 2 places. So I would move this 1, 2 places, and that's where my decimal will go straight up. So you don't have to write it like this. I just wanted to make sure that you understood. But now I'm just dividing by 3. So 3 goes into 5 one time, and my answer will be negative, of course. So 3 goes into 5 one time. Subtract to get 2, bring down the 7. 3 goes into 27 9 times, which of course is 27. Bring down the 6. 3 goes into 6 twice, which gives me 0, and I bring down the 8. 3 goes into 8 2 times, and that gives me 2. Add a 0. 3 goes into 20. Three goes into 26 times. 3 times 6 is 18. Notice that if I add a 0 again, I'm going to end up with 20 and then 18 and 20 and 18, and those 6's are going to keep repeating. So I get negative 192.26, and that 6 is repeating. When we divide by a power of 10, essentially what we're doing is just moving the decimal. So if I divide by a power of 10 that is greater than 1, like 10,000, I'm dividing by 10,000, instead of having to do the full division problem, I can just say there's 1, 2, 3, 4 zeros. So I have to go 1, 2, 3, 4 places to the left. So that would be 0.0. Those zeros are placeholders, 0.000498. 7. So it doesn't make sense for me to write out the whole problem, but this is how I would do it. Now, if the power of 10 is less than 1, like in this case, I have tenths, hundredths, thousandths, 10,000ths, we have to move the decimal to the right. And think about why that makes sense. If I'm dividing a number by something very, 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 very small, then a lot of them will go into it. So it's going to make that number larger. So in this case, 1, 2, 3, 4 places. In this case, I'm not counting zeros. There's 3 zeros, but it's in the 4th place over. So 1, 2, 3, 4 would give me 49870. So 49,870. So go ahead and divide all of these decimals and then press play to see how you did. For my first, I'm going to write it as is, but before I divide, I have to whoop whoop 2 places, whoop whoop 2 places. Put my decimal right there. 2 doesn't go into 1, but it goes into 10 5 times. Bring down the 9. 2 goes into 9 4 times, which gives me 8. Subtract to get 1. Bring down the 4. I'm starting to get a little sloppy. 2 goes into 14 7 times. That gives me 0. Bring down the 2. 2 goes into 2 1 time with nothing left over. So this is a terminating example. My answer, 547.1. For my next example, I've got 14.51 divided by 3 1,000ths. So 1, 2, 3 places. 1, 2, I don't have room, so I have to add a 0 for my third place. That's where the decimal would go. Now let's see what happens. 3 doesn't go into 1, but goes into 14 4 times, which is 12. I subtract to get 25. I'm sorry, I get 2, bring down the 5. 3 goes into 25 8 times. 3 times 8 is 24. I get 1, and I bring down the 1. 3 goes into 11 3 times, which is of course 9. 11 minus 9 is 2. Bring down the 0. 3 goes into 20 6 times, which is 18. Subtract to get 2. It's not done yet, so I add a 0. Bring down the 0. 3 goes into 20 6 times. That's 18, and now we can see that we're having a pattern here. In this case, I would write this as 4,836.6 repeating. So notice I didn't put the repeater bar to the left of the decimal. We don't do that, only to the right of the decimal. So that's my answer. And then, of course, my last one, I'm dividing by something smaller than 1, so I'm moving to the right 1, 2, 3 places. So 1, 2, 3 places would give me 7,238.